Hey everybody, Mr. Kaczynski here. Solving quadratic equations by factoring is the third method of solving quadratic equations that we've used. We used square roots and then the zero product property. This is also going to involve the zero product property, okay? But it's also going to involve factoring. So if you're not good at factoring, you need to go back to section AA of IXL and do some more work in there. All right, here we go. So these two terms here in this equation do have a common factor. They are both divisible by 2, and h. So we're going to factor that 2h out of this expression. It's going to leave us with 36h plus 7. All right, so there's an equivalent equation. Now we can use the zero product property, now that we have this in factored form, to solve the equation. One thing that h could be is 0, because if h was 0, 2 times 0 would be 0, and 0 times whatever this is, really doesn't matter, would still be 0. That's the zero product property. The other thing that h could be is negative 7 over 36. All right, if h were negative 7 over 36, then 36 times negative 7 over 36 would give us negative 7. Negative 7 plus 7 would give us 0. 0 times whatever this is would give us 0. That's the zero product property part. So that's how you can solve by factoring. All right, this one a little bit different because now we got the c value, we call it, out here. So we're going to factor this. But since the lead coefficient is 1, we can look for factors of 6 that add up to negative 5. So how about t minus 2 times t minus 3. There's an equivalent equation. Negative 2 times negative 3 is 6. Negative 2 plus negative 3 is negative 5. So now that we've got it in factored form, we can use the zero product property to say that t is either 2 or 3. If t were 2, 2 minus 2 would be 0, and 0 times this would be 0. If t were 3, 3 minus 3 would be 0, and 0 times this factor would be 0. All right, here's an interesting one because there's no b value. There's no k term. All right, so first of all, I think is 2,000, well, they're both divisible by 10. Let's divide everything by 10. So that would give us 4k squared minus 121 equals 0. Okay, interesting. So now we've got the difference of perfect squares. 4k squared is a perfect square, 121 is a perfect square. So let's write this as 2k plus 11 times 2k minus 11 equals 0. All right, so that's called the sum and difference pattern. Whenever you have the difference of two perfect squares, you can factor it like that. And now we can say that k is either negative 11 halves or positive 11 halves. This one's interesting because the lead coefficient's not 1, but we do have a perfect square leading this trinomial and a perfect square ending it. It looks like it's a perfect square trinomial. Let's find out. I think it can be factored as 2k minus 10 squared. Okay, square root of 4k squared is 2k. Square root of 100 is 10. When you multiply 2k times negative 10, you get negative 20k. Doubled is negative 40k. So that is a perfect square trinomial. We can factor it as the square of a binomial. Now this equation's just got one solution. Okay, 0 squared is the only thing that equals 0. So what would make this 0 squared? It would be 10 over 2, which is obviously 5. All right, so 2 times 5 is 10. 10 minus 10 is 0, and 0 squared is 0. One more, and this one's a little tougher and probably where the idea of using factoring kind of runs out and maybe it's not as easy anymore. First thing I got to do is write this in general form. So I'm going to add 30u squared to both sides. So 30u squared minus 40u minus 150 equals 0. Then I see that all three of those terms are divisible by 10. So I'm going to divide everything by 10. 3u squared minus 4u minus 15 equals 0. Okay, so when the lead coefficient isn't 1, we need to find factors of, well, we'll multiply the a and the c times each other. That gives us negative 45. So we're looking for factors of negative 45, all right, that add up to negative 4. So let's see, 1 times 45 is 45, 3 times 15 is 45, and 5 times 9 is 45. And I think I'll use that one because if we use 5 and negative 9, that'll add up to negative 4. So here we go. Let's rewrite this as 3u squared plus 5u plus negative 9u minus 15 equals 0. So all I've done is rewrite this, and I broke up the negative 4u into 5u and negative 9u. I also grouped, because now I'm going to do factoring by grouping. This first group, they're both divisible by u. So that would give me u times 3u plus 5. In the second group, they're both divisible by negative 3. So that would give me 3u plus 5 inside the parentheses as well. All right, so I can write this as 3u plus 5 is one of my factors. Right there, 3u plus 5. And u minus 3 is my other factor, u minus 3. So now I can use the zero product property to say that u could either be negative 5/3 or u could be positive 3. All right, like I said, if I saw an equation like this, I would not use factoring to solve it. There's other methods we could use, and we're going to learn about those. But for right now, that's pretty much all we've got to solve an equation like this. We'll get to other methods here in the coming skills. So, solving a quadratic equation by factoring. Like I said, if you're not good at factoring, go back to section AA and practice that before you bother with this skill. Good luck, and let me know how it goes in the comments.